Greetings everyone. Today I am excited to present my project. Our project group titled Multifunctional Arduino System for Environmental Monitoring and Control. This project combines multiple sensors and actuators to create an automated system capable of monitoring temperature, soil moisture, motion, humidity, and light intensity. It also responds with appropriate actions. For example, activating fans, water pumps, or alarms based on specific condition. Let me give you an overview of how the system works. At the heart of this project is an Arduino Uno. Here, we are using a platform of Tinkercad, which serves as the brain of the system for the Arduino Uno. It collects data from 5 different sensors. The first sensor is a temperature sensor for monitoring room temperature. The second one is a PIR motion sensor for detecting movement. And the third one is a soil moisture sensor for assessing the dryness of the soil. The fourth is a humidity sensor for checking atmospheric humidity. And the last sensor that we apply is a light sensor for measuring light intensity. Based on the data from this sensor, the system performs action, for example, activating a fan using a servo motor if the temperature is too high, triggering a buzzer and LED when motion is detected, and turning on a water pump when the soil is too dry, adjusting a light source brightness based on ambient light, and lastly, lighting up a warning LED if humidity is too high. The system displays real-time data on 3 LCD screens, making it easy to monitor all environmental parameters at a glance. So we move to the main components on this project that we use. The first one is the Arduino Uno, where the microcontroller that process all the inputs and controls of the output. And the second one is the TMP36, where to measure temperature, a PIR sensor to detect motion, soil moisture sensor to check the soil moisture level, servo motor to control the fan's position, DC motor and pump to water plants, buzzer and LEDs for alarms and status indication, and a 3.6x2 LCD to display sensor readings and system status. All components are connected using breadboards powered through the Arduino. So we move on to the system on how it works. So first, we start the Arduino, and then as you can see, the LCD start to respond from the motherboard that is connected from the Arduino. So as you can see, the first LCD shows for the temperature reading, and the second LCD shows for the motion sensor that is collect data from the PIR sensor, and the third one is for the humidity sensor that is for reading for the soil moisture. So for the first one, that is the temperature, when the temperature does not exceed the threshold of the amount of the high degrees Celsius that is set in the system, the fan will turn off. However, when we increase the temperature, when the temperature go high, the fan is off. But when when the temperature goes high, the fan turn on, and so the servo motor start to rotate here. As you can see, start to rotate. And then we move on to the second second sensor, that is the motion sensor. That is, we use the PIR sensor. So as we guide when a motion is detected in region area here, the sound, the alarm will go on and it will make a loud alarm. And at the LCD, it shows the motion is detected, so alarm is activated. However, if we move when the motion is at this area, so the alarm will not activated. So alarm go off. See, there is no motion detected. So that is the second part of this sensor, that is from the PIR motion sensor. And then lastly, we go to the humidity sensor. Here, at start, it's stated that the soil is dry, so the pump turn on. When we move, so when the soil, is stated that the level of the soil moisture is labeled as wet, so the pump turn off, and then this motor will rotate and close the valve. So that is the explanation for each three of the sensor that we use in our project. And then we go on to the coding explanation. As you can see, we include libraries for controlling the servo motor and LCD, such as the servo.h and the liquid crystal I2C.h. The pins for each sensor and actuator are defined for easy references. For the setup function, this is where the system analyzes all the components. For instance, the LCD display initialization message. The servo motor is set to its starting position and pins are configured as input or output. So we move on to, at first here, we declare all of the input that we need to add in our Arduino. For example, temperature sensor pin, we connect with A1. Servo pin at 8 is for the servo motor. LED pin temperature 10, connect at D10 for the LED for the temperature. Pin sensor pin, buzzer, soil sensor pin, and as you can see, there is continuously connected at the Arduino. And these are for the threshold values, where for each of the sensor, the value have their threshold value to make either the sensor to turn. When it exceeds the threshold, the sensor will be functioning, so that the sensor will function. And now we move on to the void setup. The main logic runs here. Each sensor is read and the corresponding outputs are controlled. For example, the temperature is calculated from the TMP36 sensor analog reading using a formula to convert voltage to degree Celsius. Here. And then for soil moisture, the analog value is checked against a threshold to decide whether to turn the pump on or off. For the motion detection, the PIR sensor triggers a buzzer and LED if motion is detected. And finally, the LCD screens are updated with real-time sensor data and status message. And these are the part where the message that is appear on the LCD, and this is the coding. As for the void loop that I explained earlier about how the calculation for the voltage, temperature in the system, and here is a serial pin where it will display on the LCD. And lastly, for the motion detection system, also the same, where there is coding for the data that we want to display on the LCD, and the calculation of the hertz tone for the motion detection sensor. And this for the soil moisture system, also the same from the previous from the motion detection. We use if and else statement to run either each one of them when the sensor from the humidity sensor reading either it is wet or dry. So, and lastly for the light control system, where the calculation we stated, and then we also use if and else statement, and we use this serial pin to display on the LCD. And same also for the humidity system, where just the same from the 3 or 4 from the previous system. So I think that's all from our group in presenting on how our system work, and I hope that every one of you understand what is our project group, our group intent in doing our project, and hope to leave good comments. You can leave good comments, and you can ask for extra explanation, and I will give you the extra explanation in the next video. So that's all from me, and before I end my video, I will mentioning the members that has completed this project. That is, first is Muhammad Dini Syafiq, Amir Rashid, and Muhammad Fudal, and also the person that is presenting this video, that is me, myself, Muhammad Iqbal Adam. So I appreciate all for the time to hear this video, and see you guys. Thank you very much.